Hello friends, in our earlier lectures we have seen shortest root problem. In fact, shortest root problem we have used to understand the concept of dynamic programming. It's a very natural idea of optimization. In this idea, the optimum solution is obtained based on the concept that return till any stage is compiled based on the return of that stage. That means value of the objective function. Return means value of objective function for that stage, and the optimal return till previous stage. This concept developed while learning shortest root problem, we have implemented for solving capital budgeting problem, for solving cargo loading problem, and also the reliability problem. In the reliability problem, we have tried to design optimum electronic circuit, that is the electronic circuit for maximum reliability within the given amount of money by using dynamic programming. One thing is implied by whatever we have said earlier, that the problem is to be broken into multiple stages, and the optimal return is to be found for each stage, and the optimal return for every value of the state will be used in the subsequent stages. When we go from one stage to another, that time the return till that stage, objective function value till that stage, is comprised of the return for that stage and the optimal return for the remaining value of stage from previous stage. So the terms which are important in dynamic programming are: one is stage, because the problem is to be broken into multiple stages intelligently, right? And stage will be used indicating by variable I. Variable B will be used to indicate another important thing in dynamic programming, that is state. Okay, state is the value, different values which we give for the limit of the constraint. For example, in cargo loading problem, we had the limit of cargo of 10 tons. Okay, so we assume that the cargo capacity, if it is 0 tons, 1 tons, 2 tons, 3 tons, 4 tons, and so on up till 10 tons. Okay, we have found out optimal return if we have the states of 0, 1, 2, 3 up till 10. Okay, so state is nothing but the different values of the constraint limits. Okay, state is a variable. Constant limit, otherwise we assume to be a constant, but in dynamic programming we have to give it, we have to consider it as a variable, right? Then another thing, we used to write the states this way in our tabular approach, right? Then we used to write alternatives here. Okay, then our return function used to be the function of state and alternative. There is one more variable called bi minus 1. Bi minus 1 stands for remaining value of state for previous stage. I minus 1 is our previous stage. Remaining value of state, B is the value of state, but now Bi will be remaining value of state for previous stage if previous stage exists. Why do I say that? Because previous stage will exist if it is second or more stage. For first stage there is no previous stage. So in previous stage there won't be a term called as Bi minus 1. Right? R star stands for optimal return, right? And I minus 1 is for previous stage. R star I minus 1 is the optimal return for previous stage for remaining value of state, right? Ri is the return till ith stage. Okay, it is comprised of two components. One is return due to current stage, and another is optimal return till previous stage. Okay, mathematically it is written as RSI, means RS stands for return due to current stage, I stands for current stage. RS means stage return, and another R star I minus 1 is the optimal return till previous stage, right? And in between you are seeing the plus sign inscribed in circle. That stands for some operator, might be plus, might be multiplied by, depends upon how you are combining, how you are chaining previous return with the current return. That is given to you by the kind of objective function you are dealing with. Okay, if the returns are added, then there will be plus sign in between. If the returns are to be multiplied, then there will be multiplied sign in between. So that operand is itself variable, right? R star I is the optimal return for current stage for BI, means for state variable, right? So this all declaration which we have made in this table is nothing but the flow which you will have to take care in every stage while you solve the problem. So far all the problems which we have solved by using a tabular approach. That was a very convenient approach. The skeleton for that table, if you recall, you used to have state written here. For example, in cargo loading problem, you had the states like 0, 1, 2, 3, up till 10 you have written here. Then here you had all the alternatives pertinent to the stage you are dealing with. Okay, all the alternatives, and also you were writing the corresponding returns pertaining to each alternative in each of the alternative, if you recall. In this main body of the skeleton, we used to write return. Return used to be the function of, or is the function of, state and alternative, right? And in first stage it was simply a stage return, but second stage onwards this return used to comprise two components. One, the stage return due to selected alternative, and another component was optimal return from previous stage for the remaining value of state. Okay, you once again look at those problem with this thing in your mind, you will understand this better. Then lastly, in the last column, we used to find out optimal return for the current stage. For every state, we used to find optimal return. So it was the function only of state. R1 star B stands once again for optimal return for given state, right? If the presentation, this kind of presentation is good for the problem which have discrete data provided to you, you don't have to formulate the problem, and therefore you don't have to deal with the trouble of formulation. You don't have to deal with the trouble of variables in the dynamic programming if you use if you use tabular approach. Okay, but if the variables are there given in the problem, and if they are continuous variables will be continuous. If variables are not to be selected from the set of values, variable is not to select the values from certain set of values, or it is not integer or something like that. Okay,